Now we have the chemical engineering group, and they're going to speak about chocolate.
Hello everyone, my name is Juan Mugallen, I'm from Bogota, Colombia.
Hello everyone, my name is Bronson Heath, I'm from Philadelphia, Pennsylvania.
I'm Ashley Earl from Long Island, New York.
I'm Isabella Gantier from Fort Myers, Florida.
And I'm Mark Woodson from Las Vegas, Nevada.
And we're the chemical engineering group. Today we're going to talk about chocolate manufacturing, which is what we've been studying and researching for the past 2.5 weeks.
So we had two project objectives. The first one was to produce chocolate made from unsweetened baker's chocolate and other ingredients that was provided. And the second objective was to learn about the different chemical processes involved in the manufacturing of chocolate. So what we're going to talk about today is the background of the chocolate industry itself. We're going to be talking about the chocolate manufacturing, most importantly the chemical processes. Then we'll be talking about the tests we did during the last couple weeks, as well as our brand.
So a lot of people may not realize this, but the chocolate industry is actually huge. Today, it's worth over $98 billion. Some of the main manufacturers include Nestle, Lindt, Hershey's, Cadbury, and all the other manufacturers we know and love. Mars Candy, located right here in the USA, is actually the world's largest producer of candy, manufacturing a net profit of over $18 billion last year.
So the main producing regions of the cocoa are mostly located in West Africa with a few exceptions, like Indonesia, which leads to my next slide, which is an Ebola outbreak that recently just came out in May this year. It is the deadliest that has ever been recorded in history, with 632 deaths, and 90% of the people that get it eventually die because there's no cure for it. Because the demand for chocolate is increasing and the workers are decreasing, the cocoa price is increasing too. That's why Hershey's recently raised the price of all their chocolates and candies by 8%.
So chocolate is a food product that is derived from the cocoa bean, and two types of chocolate are dark and milk. Dark has a 40 to 90% cocoa product, and milk has 10 to 20% cocoa product. Milk chocolate has a lot of additives in it, such as sugar, milk, and vanilla. For the texture, you want it to be smooth and creamy, not gritty at all. And for desired properties, it depends on the company. Mars, who makes M&Ms, would want their chocolate to not melt in the customer's hand, while if it's a Hershey bar, you want that melt in the mouth taste, so it would not be hard, be very smooth.
So now we're going to move on to talk about chocolate manufacturing and the chemical processes that are involved in this. Some of the main ingredients in chocolate include cocoa butter and milk. Milk is a very important ingredient because it contains the milk sugar of lactose, which helps to cut down on the bitterness of the cocoa bean. Other ingredients include sugar, milk products, and vanilla flavoring, which is often a synthetic chemical called vanillin.
So there are three phases involved in the manufacturing process. Phase 1 involves the handling of raw materials. Phase 2 is the preparation of all ingredients that will go into the chocolate. And phase 3 is the processing of cocoa nibs. So phase 1 is when the growing of the chocolate beans itself take place. Cocoa trees will begin bearing cocoa pods around 3 to 4 years, and they will yield about 20 to 30 pods each year, which will produce about 450 grams of chocolate. After this, they will be harvested by workers, and this is a very strenuous and laborious task. They will cut the pods from the tree and then split them in half. After the pods are split, they will be cleaned of a white liquid inside the pods, and they will be placed in a pile for drying and fermentation.
Phase 2 is all about preparing the cocoa beans for further manufacturing. It starts off with fermentation, which often takes place outside, where the beans are exposed to bacteria and rain. So it's very important that after fermentation, these beans are dried before they're transported. If they're transported while wet, the beans can grow mold and no one wants to eat moldy chocolate. After they're transported and arrive in a factory, the beans are then roasted and winnowed. Winnowing means that the beans are put on a conveyor belt where they are then crushed and the shell of the cocoa bean is separated from the cocoa nib, which is the actual desirable part. So here in these pictures, you can see the fermentation of the cocoa beans taking place outdoors and the roasting of the cocoa beans.
Okay, the third and last step to making chocolate is the actual separation of the nib, which is the center of the cocoa seeds, into cocoa powder and cocoa butter. So the nibs are put through a hydraulic press, which removes 50% of the cocoa butter, and the rest is crushed into what is known as cocoa powder. Later on, the companies can recombine them to change the intensity on the chocolate. After that, the conching process comes in, which is what gives it the texture and consistency. So what happens is they put the cocoa butter, the cocoa powder, and more ingredients in a huge mixer, and those two rollers spin around, creating kinetic energy that creates heat, which heats up and melts the chocolate and fuses all the ingredients together. And with the airflow that the rollers are giving the chocolate, it also helps get rid of all the acids. This is the last step to remove all the impurities.
Now from a chemical engineering point of view, there are two main chemical processes that occur during the production of chocolate. The first one is fermentation. Fermentation is just a natural chemical process in which yeast and bacteria convert sugar into ethanol, and that helps stop the growing process of the seed so that the seed does not sprout during transport. Also, crystallization occurs during the production of chocolate. Crystallization is obtained through tempering, which is basically the heating and cooling of the chocolate. By doing this, it gives the chocolate the characteristics that customers enjoy most, which is the snap and melt in mouth characteristics. And to the right of the slideshow, you can see in the stage one, this is in a hot solution with the orange hexagons being solutes and the yellow triangles being impurities. As you cool down the solution in the end at stage 6, you can see that the orange hexagons all turn into one big solid, while the yellow triangles are separated from the solute, so that you get a pure substance, which is what companies want most. Also, you can see how many industries use these similar processes that people use in chocolate making. Crystallization is used in pharmaceuticals, cosmetics, as well as the food industry, since these industries want their products to be the most pure. Also, you can see in fermentation, for industries using fermentation, since you add yeast to the bread, and the yeast converts the sugar within the bread, and it creates CO2, which gives rise to the bread. Also, when you add sugar and yeast to an alcoholic beverage, the yeast converts the sugars into ethanol, which turns into alcohol, which adults love today.
This leads us to testing. We perform 3 types of testings in our lab work: hardness, taste, and viscosity. Using a bladed instrument, we made an incision in the chocolate, then measured that with a ruler. The wider the incision, the softer the chocolate. Then we also compared brands for taste. Hershey and Lindt were a lot sweeter than Ghirardelli or Godiva. And lastly, for viscosity, we boiled down the chocolate, then timed the amount of time it took to pour the chocolate from one beaker to another.
So for the design of our product, Nova Chocolate, there are 3 different components. First, we will begin talking about the ingredients, the process of making it, and also the overall evaluation of our product. So for the ingredients, we decided to use 49% of Baker's chocolate. Baker's chocolate is 100% cocoa, and it is extremely bitter if you eat it alone. But although it does it does contrast with the other ingredients that we use, such as dry milk and sweetened condensed milk. We use 4% dry milk and 30% of sweetened condensed milk. Sweetened condensed milk is milk and sugar. It gives off a very sweet taste, and that helps with the chocolate as well as the consistency. Also, we use agave, which is nectar, and that also helps with the sweetness as well as the consistency of the chocolate.
So in the process of making our chocolate, we first heated it. We boiled it down from a baker's bar, then we stirred it, mixing in ingredients like agave, condensed milk, vanilla, and other sugars. We also tasted it, and we tempered it, which is the process of mixing. It's mixing techniques as well as heat control. If you mix it too quickly, the chocolate will have the consistency of fudge, but if you mix it too little, then the chocolate will not have the ingredients all mixed throughout the chocolate.
So in the evaluation, we found out there were some improvements we could have made. The consistency of the chocolate could have been a little better. As Isabella previously noted, if you mix chocolate up too much, it would turn to fudge, and our chocolate was more fudge-like than chocolate, so it didn't have that snap or melt in your mouth characteristics as everyone wanted, but it's still a good chocolate. Also, the taste could have been a little better. It's because Baker's chocolate is 99% cocoa, it's a little bitter, and it takes a while to add ingredients and make it less bitter. So the taste is not as good, and it could also have been a little smoother.
So we decided to name our chocolate Nova Chocolate because ultimately, if it were being sold, we would want it to be sold in the Villanova bookstore. We decided to use browns and subdued colors with a simple design because we're marketing it to college students. It's not really a chocolate for like elementary school students. We thought chocolate would be perfect to market to college kids because there's a chemical in it called theobromine, which is a mild stimulant similar to caffeine. So we thought college kids could use it on all those late nights they use studying. So we're gonna pass a few around. There's not enough, but try and share with the people around you.
In the end, we would like to emphasize how the process of making chocolate is a lot more complex than people tend to believe, since there are a lot more processes between the first harvesting the cocoa seed to the actual production of the chocolate that people eat today. Also, we'd like to show how chemical engineering can span over many different industries and products. For example, the two examples that we use, fermentation and crystallization. Companies such as pharmaceuticals and the alcohol industry use these types of processes for their industries, and those two industries are both extremely large in the world today. And
I'll be the first to testify. It's better than I thought it would be. It tastes like a truffle. It's good. It's very good.
thank you.
Thank you.
Good presentation. Thank you.
Yes.
I've always been convinced that chocolate is a food group, so I'm glad you guys did.
Yes, Sam.
You were talking about separating acids during conching. So how does the pH of chocolate affect how it tastes?
Well, the more acidic the chocolate is, the more bitter it is, and the more basic it is, the milkier it is.
Well, what's the one you gave us the other night that tasted really bad?
That's the baker's chocolate.
That's 99% cocoa.
Oh, yes.
That's not going to taste very good. Any more questions? Comments?
All right, we'd like to take this time to thank the entire Villanova staff as well as Dr. Kamoli and the two student advisors that were helping us during this process. Also, we'd like to thank our lead staff as well as the room advisors that have been here this whole time. Without all of you, we wouldn't have had this great experience. Thank you.